This article is related to fractional-order stochastic modeling of turbulence with memory effect using the MATLAB. So in this article, basically I have just written the stochastic model for the turbulence based on non-local temporal dynamics introduced through a capto type fractional derivative. And this model is basically proposed by the Grunwald. Latnik was one of the scientists who proposed this model with a couple of linear, nonlinear dissipation, viscous damping, and stochastic forcing. Ensemble the simulations are performed to analyze the velocity fluctuations, energy variation, and dissipation mechanism in the reduced order turbulent system. So the model basically successfully reproduces the key statistical features of turbulence, including the intermittent behavior and non-Gaussian energy transfer. Power spectral analysis basically reveals the scaling behavior consistent with the classical Kolmogorov -5/3 law over an intermediate frequency range, and the structure functions of second and fourth order are employed to quantify the intermittency across the multiple time scales. So as an abstract with the keyword and introduction, I have written according to the fractional turbulence. So this is the main diagram of the fractional turbulence, in which we need to check out the fractional turbulence velocity evaluation over time, phase space trajectory of turbulence velocity, and then ensemble average, and as well as energy spectrum compared with the Kolmogorov. So the thing is that fractional turbulence, traditional turbulence model basically are typically based on integer order differential equations, which often fail to capture memory effects and anomalous transport observed in real turbulent system. And in the recent years, fractional calculus has emerged a powerful mathematical tool. Basically, this is an introduction like how the fractional calculus is used and what is the importance of the fractional order derivatives naturally incorporates the memory effects have been successfully applied in the field as viscoelasticity as well. So here's the background and motivation as well, in which I have just written like how the features are particularly evident in the intermittency, anomalous diffusions, and this is a fractional calculus related work, and objective and contribution of this work. This is basically fractional order stochastic turbulence model that incorporates the temporal memory effect through the capital type derivative, and the model combines the nonlinear self interactions, viscous dissipation, and the stochastic forcing to represent the essential turbulent mechanisms as well. Physical interpretation of fractional memory in turbulence, as well as a numerical strategy with the reduced order modeling. And this is a statistical, diagnostic, and scaling analysis, which is basically provide us Kolmogorov scaling check frequency according to energy spectrum. Kolmogorov scaling remarks accordingly, and significance and scope as well. Significance is that it is a useful platform for the studying of anomalous transport and non-local interactions in turbulent flows. This is a problem statement with the mathematical approach. I have used the memory effects with the computational efficient approach, and next one is the capito fractional derivative of the order, which is non-linear, and this is its equation used in the MATLAB, and this is the physically interpretable equation of the vector derivative, and this one is the numerical experimental equation. This is the alpha based equation accordingly. Yes. Okay, and so here is the and methodology. Yes, methodology. This methodology provides us the complete sample average statistic parameters, and next one is the structure functions design and MATLAB simulation. In the design and MATLAB simulation, I have added the fractional turbulence velocity graph. This is a phase space attractor, and this one is the main turbulent energy, and this one is the energy dissipation rate and energy spectrum and Kolmogorov -5/3 law, and the structure functions as well. This is the turbulence intermittency and velocity autocorrelation with the results and distribution discussion, as well as the conclusion and references as well. Let me just give you the MATLAB demonstration accordingly. See, these are the output results accordingly. Structure functions, energy spectrum, energy dissipation rate, mean turbulence energy, phase-space structure, fractional turbulence velocity. So if you need to ask anything, you just ask me, I will answer your questions. Thank you.